In this video we're going to look at the patch sequence capabilities of ColourSpace, because there are some fairly unique functions built into the way patch sequences work, specifically that users can define their own patch sequences to add additional colours or grayscale values or whatever into the measurement sequence. It also means that the patch sequences can be made to be exactly correct for any given TV that has, say, a 12 grayscale or a 10 grayscale or a 21 grayscale step patch sequence for grey, with each patches not necessarily being equally spaced or what have you. You can make sure that you are working with exactly the correct stimulus when manually measuring and calibrating such TVs. So we'll start by just popping out a few graphs so that we can see what's going on as we're playing with this, and we'll pop out the patch window as well, and then we can actually start to look at the way patch sequences work. And the most obvious menu is characterization, where there are a number of inbuilt sequences: grayscale, primary only, memory colors, gamut sweeps, and so on. And each one of those has a very specific function to perform. So for example, grayscale, or let's say primary and secondary, will perform a 21-step grayscale and 21-step red, green and blue profile, so that we can see the underlying capabilities of any given display. At the moment we are targeting Rec. 709, 100 nits max and 0 nits minimum, just as a starting point, and the profile has already had a nominal 0 and 100 nit black and white point put in based on the white for Rec. 709. And if we just connect to our colorimetry probe, and we will start a primary profile, and that will step through each patch in turn, with the probe taking measurements and plotting the data directly onto the CIE graphs. The other graphs will not populate initially, as the data in the 1D graphs is presently only updated after an automated sequence has finished. But we can look at the 3D graphs and get a feel for what's going on. So for example, here we have measured the grayscale, and we're now building up the red primary sequence. And you can see, looking at this, that in the grayscale we have an issue in the sense that the measured patch for white, for example, is higher than our target of 100 nits, and also slightly offset. So we have a color temperature difference and a luminance difference. Well, the luminance is because we obviously were targeting 100 nits for peak luminance. And we can update that when we have measurements made for that as well. We can also look at that in the cube view to get a feel for, here we go, a bit more of the way that the information is presented to us. And you can see again there the luminance offset as well as the color temperature offset. And that will carry on, and we'll cycle through the primary and secondary colors. And there we have the profile complete for primary, secondary and the grayscale. And looking at the various graphs, we can see what we've got in the way of gamut and gamma compared to the target color space of Rec. 709. You get a good indication here looking at the way that the green, for example, is both over gamut and is higher than our initial target of 100 nits. Obviously we've got 110, 111 nits, and if we just update our target with those measurements now, you can see that the luminance value is now tracking, but obviously we still do have a gamut shift. Actually green is slightly lower in luminance compared to our white, which just shows that the display is obviously not completely accurate based on the Rec. 709 color space. All the 1D graphs have now been plotted as well, and we can see the RGB balance offset, the white point color temperature being slightly different. Obviously with the gamma, the EOTF, we can see that it is brighter, which means a lower value gamma in the darks, in the shadows, and it is actually darker in the highs, and that is again shown on the differential, which shows us that it is brighter in the dark area and darker in the bright area compared to the target of 2.4 power law, that is Rec. 709. And then our little RGB zooms, we can just recenter those so we can see again the difference compared to our target blue or green compared to the actual measurements. Quite a difference in the gamma on the green, obviously, and in red a little bit less, a little bit less so. There we go. So it gives you an idea of the current state of the display. Now this is all well and good looking at Rec. 709, but the display itself is obviously in its uncalibrated state, so we obviously have a significant difference. So one of the things that we're going to do to assist us in understanding the way these patches are working and what we're looking at is we'll extract from that profile that we've just taken a ColourSpace. So we will save the profile. We'll just call it ASUS test, and then from that we can extract, hope I can see it, there we go, modify, and we're going to extract a ColourSpace from the profile, and that means we can now compare to our new ASUS test extract, and it just means that everything lines up a little better because we're now seeing everything actually compared to itself rather than compared to Rec. 709. Obviously we still have a gamma variation because the variation was obviously different high to low, and that won't have changed because we are still comparing to a power law. Obviously the extracted power law won't be 2.4 anymore. In fact, if we look at that, we can see that the extracted ColourSpace is actually 2.389, so it's very close, but that's the average power law extraction from the profile that we've just taken. There we go, and we update that so we can now see all of it compared to our measured 110.9 nits as well as the 0.137 nits black, and with the extracted gamut and gamma. That's all well and good using a preset patch sequence, but we can do that with something that is, let's say, user generated. So if we wanted to add more information into the grayscale, for example, we do have a grey only large profile within ColourSpace, but we can actually use manage to choose a different sequence of our own design. We can export the sequence, so for example we've got grey only large here, and if we export that onto the desktop, save that, then we can actually look at that because it is just a CSV list with our 33 patches of grayscale plus our 3 patches of red, green and blue with the slightly lower than 100% value of red, green and blue that we use. And that can be used to modify, to generate any patch sequence that a user would like. For example, if we import a patch set, we can choose something like, here we are, we have somewhere in here grey large, there we go, 46 point grey only. So this time that would actually profile with a 46 point patch set rather than the 33 grey plus 3 red, green and blue we just had. And if we just close that, we can prove that by literally selecting custom as our patch sequence, and if we start that again, it will this time measure a, as it says here, 46 patches, which is 43 grayscale plus 3 red, green and blue. And as it gets to the end, all of the graphs are updated. There we go. And we can see now a much higher resolution of measurement in the grayscale, still with the single red, green and blue measurements as before. And if we look at the 3D, you can see there in the volumetric graph there's a lot more information in the grayscale than we had previously. It's not just the quick profiles that can use user patch sets, but any sequence that you want. So if we look in our manage library, we can actually load in any number of these sequences to do full volumetric. So there's a pseudo random optimized set there, which uses a patch set that is not based on the cubic layout of the standard patches within ColourSpace, but gives us the ability to use, as I say, any sequence that we choose to use. Obviously with any patch set we can still use drift compensation, or use stabilization patches, or use pre-roll sequences, which again are just CSV patch sets. So somewhere here we have, here we go, pre-roll 100 black and white. So what this will do is now pre-roll with each patch being, let's do 0.25 seconds pre-roll before it starts actually using our pseudo random optimized sequence. So if we hit start, yes, it's telling us there's data there, we know that, so we're happy for that to be overwritten. And you can see now that it's flashing through the white and black patches, which are 16235 value in this case, plus the black stabilization patches, just as a way of warming up the display before it actually starts on the 9400 plus patches of the actual sequence. And you'll see in a moment, as it reaches the full 100 patches in the pre-roll, that it will kick off now. There we are, and it's starting to read the actual patches, which will also have drift compensation inserted and stabilization as required. And again, the graph is now updating because the measurements are now valid and not just the pre-roll that was warming up the display beforehand. And if we abort, it will update the graphs with the partial data, so we can actually see what data has so far been recorded, in case there is something there of interest that we need to go back and look at before restarting the profile sequence. But as was said earlier, one of the areas where we have a good use of patch sequences is in manual measure. Normally we would define patches using the sliders and just take single measurements as required, and that works exceptionally well. If, say for example, if we want to do a grayscale, let's clear out the graphs and actually look at doing, compared to our target ColourSpace, which is still the ASUS test, so we're still comparing the display to itself. If we go back and actually use these sliders, we could do a grayscale where we can use percentage to step through 10% on each patch. So for example, now we're parked on black, and if we take a measurement, the black reading is updated on all the graphs, so we can see it here on the RGB balance as well as the CIE graphs. If we now just click above the slider, it will jump 10%, that's what we've set it to. We can take another measurement and it will now update the next patch at 10%. Step forward again, measure, and so on. So we can literally step through, in this instance, at 10% intervals and just take new readings each time. If we want to go back and actually take the reading from an existing patch, we can either zoom into it and simply click on the patch, and that will jump to the information for that patch. So patch 2 tells us it is 026 in value. The patch has gone to that colour both in the sliders and the patch on the screen, and we can remeasure, and just that patch is remeasured, and then we can step forward, so we know that we've already done 1, 2, 3, 4, 5, so we want to go to patch 6, so we can step through to the next patch, measure, there we go, and the next one, measure, And we can continue to do that. We can obviously separate out the sliders and choose to do peak red, green and blue. So measure red, green and blue. And obviously, just to finish off, we could do a white. We're obviously missing a few in the grayscale, but we've now got pretty much the standard values for that. Just using the sliders to try to match the requirements for the display's CMS controls. But we can actually move away from the manual measure sliders into presets and pick up a set that will do this automatically. So for example, if we look at, say, memory color list, and you see that now, that populates all the patches for both grayscale, 21 step in this instance, plus memory colors, red, green and blue, and primary and cyan, magenta, yellow secondaries. And we can either use this to automatically run through that sequence as if it were a characterization, or we can use it to manually step. So for example, if we click Auto Advance and measure, it will now step through each of those in turn and update the patches manually, update the patches automatically while stepping through each of the patches in the sequence. Obviously the target zoom and RGB widget boxes will give you information on that, which you can look at as chroma only, HSL, or basically delta E, which is the RGB including the luminance value. And you can see that as that will continue to step through, it will build up in exactly the same way as a normal characterization a profile of the display using the defined patches. And there we go. It has now completed both the gamma, looking at the EOTF, and obviously the normal gamma graph, that's a differential graph, that's the standard EOTF, as well as the RGB balance, the primary color points that we've zoomed into, and obviously all of the data in the primary window. And we can again see the kind of issues or errors that we have in the graph, and if we again just update the min and max, we get an idea of the volumetric errors. So you can see that all these points are showing us that there are volumetrically errors within the display compared to the primary colors that have positioned the gamut. Now that's just using it to do an auto advance, but if we delete all the points again, we can actually use these to manually do exactly the same, but while making adjustments if we're doing manual calibration. So we're on black, we can tell it to repeat, no auto advance, and measure. And ColourSpace will now continue to measure and remeasure black. But you can see we can now adjust the display manually while measuring black. When we step on to the next patch, the last measurement will be saved and it will build up for us the profile using the last measurement made. Now if you don't want to use repeat, obviously you can just manually remeasure. So when you've come to the end of an adjustment, you may want to use repeat while making a manual adjustment. But then at the very end, you may want to take a single measurement just to make sure that it is a stable measurement on the last read before moving on to the next patch and repeating that. But as before, you can see that literally stepping through each patch in turn and taking a measurement builds up all the required data to give us a profile of the display in question and the characteristics that it presently has. If we just finish the grayscale, and we'll do the red, green and blue. And there we go. We now have a profile of the display showing us the underlying basic characteristics, but each one done manually. And obviously this sequence I've used is one that we just use for a basic assessment, but it could be that each of these grayscale patches perfectly aligns with your particular TV and the controls that are built into that TV's colour management system to enable you to manually adjust the TV to exactly the right value for gamma, RGB balance within the grayscale and so on. So it is worth getting to grips with the user patch sequence capability of ColourSpace because it is a very powerful tool.